There are many popular places to find quadratic models in physics, and if you take a physics class, you're going to see a lot of them. In this course, we're only going to be treating one, and that is the case of an object moving with a constant acceleration. If an object is moving with a constant acceleration, call it a, some starting velocity, v0, and some starting position, s0, or sometimes we'll call the position h if it's a height, or x if something is moving just left to right, then its position at time t is given by the function s of t, or h of t, or x of t, is a half at squared plus v0t plus s0. Note that all of these numbers can be negative numbers, and in physics we think of negative as just being backwards. Sometimes we'll give you this model with the numbers already filled in, and sometimes we'll tell you what the numbers are and have you plug them in. So for example, suppose a ball is thrown into the air from a height of 5 feet with an initial velocity of 40 feet per second. Its acceleration is negative 32 feet per second squared. We want to do three things. We want to find its height after 2 seconds, find out when it's 29 feet from the ground, and then find out when it lands. So plugging into our equation, I'm going to call this h because it's a height. The initial height is 5 feet. The initial velocity is 40. The acceleration is negative 32. So I'll get h of t is 1/2 negative 32 t squared plus 40t plus 5. So that'll be negative 16t squared plus 40t plus 5. To answer the first one of these, I'll find h of 2. Pause the video now and see if you can compute h of 2. I just plug in 2 for t, right? Negative 16 2 squared plus 40 times 2 plus 5. 2 squared is 4. 4 times negative 16 is negative 64. Plus 40 times 2 is 80. Plus 5. And I'll get 21. So the height after 2 seconds is 21 feet. At what time is it 29 feet above the ground? I'll need to solve the equation negative 16t squared plus 40t plus 5 is the height 29 feet above the ground. I'll need this in standard form as negative 16t squared plus 40t minus 24 is 0. Looking at this intently for a few minutes, I do see a common factor of 8. I would probably be able to divide through by maybe negative 8 and be able to solve this by factoring. But that seems like work, so I'm going to use the quadratic formula. And now I'm going to plug these into my calculator, and I'm going to get t equals 1 or t equals 1.5. So the ball is 29 feet off the ground at 1 second, presumably keeps going up past that, comes back down at 1.5 seconds. The last thing we want to know is, when does the ball land? Pause the video and see if you can decide what equation to set up in order to figure out when the ball lands. Pause the video and try it now. . All right. When the ball lands, its height above the ground is 0. So the equation we'll need is height above the ground equals 0. Nice thing about this equation is it's already in standard form. I certainly don't see a way to factor that. Let's pull out the quadratic formula. T equals negative 40 plus or minus the square root 40 squared minus 4 times negative 16 times 5 all over 2 times negative 16. So I'll get T equals negative 40 plus or minus the square root of 1,920 all over negative 32. 1,920 is not a perfect square, so the best I can do is get a decimal approximation for what time the ball lands. Let's figure out decimal approximations of our solutions. The first solution will have negative 40 plus the square root 1920 over 2 times negative 16. So the first solution is t is about negative 0.12. That doesn't look very useful. We'll think about that in a minute. The second solution is going to be the minus solution. So I'll go back and edit that to be minus. The second solution will get t is about 2.62. Now looking at this first solution, does it make sense for a ball to hit the ground 0.12 seconds before it's thrown? No. This solution doesn't make sense. We'll throw it out. Which means we're left with t is 2.62 for when the ball lands.